We are starting 6.1, solving rational equations, and I'm going to show you how I would solve these equations. If you have a different method, as long as it's mathematically sound, I'm cool with it. But I think if you give this a shot, a John Wilkes Booth, if you will, that you will enjoy the way that I'm doing it. So the one thing you got to be careful about with these problems is if you have a variable on the bottom, you have to find excluded values, things that the answer could not be. So we are trying to solve the equation. I currently have a denominator. I don't typically like having denominators, so I like to get rid of them at the beginning. My denominator is x minus 4, so I'm going to multiply both sides of the equation by x minus 4. I'm allowed to do that because of the multiplication property of equality. On the left, I'm multiplying and dividing by an x minus 4. They cancel, leaving me with a 4x plus 7. On the right, if I distribute the 7, I'm going to get 7x minus 28. Then it's just a regular equation with no funny business. I'm going to subtract 4x from both sides. I'm going to add 28 to both sides. I'm going to divide both sides by 3. 3 does not go into 35 evenly, and it does not reduce. So I think my answer is 35 thirds. I don't know for sure, because I have to also make sure that I know that my denominator can't be 0. X minus 4 can't be 0, so x can't be 4. Now, as long as this answer doesn't conflict with what the answer can't be, then that is your answer. It does not conflict, so the answer is 35 thirds. Second example. We got this hot mess here. I have a fraction once again. I don't want that fraction. I'm going to multiply both sides by n minus 5. Notice I put it in parentheses because I'm multiplying by more than one term. I did the same thing on the last problem. On the left, if I distribute the 3, I'm going to get 3n minus 15. On the right, the n minus 5's cancel, and I get 4n squared plus 12n minus 10. Since I have exponents, I want to get all the terms on the same side by subtracting 3n and adding 15 to both sides. And I'm going to get this. To continue, I'm going to have to factor, and to factor, I'm going to have to split the middle term and factor by grouping. I need two terms that multiply to get 20n squared. That's the product of the first and last term. And add to get 9n. That's the middle term. So numbers that work for that are 4n and 5n. 4n times 5n is 20n squared, and 4n plus 5n is 9n. So the middle term becomes those. Once you split the middle term, factor by grouping, making sure there's a plus sign between the two terms. GCF of each group. GCF of the first group is 4n, leaving me with n plus 1. GCF of the second group is 5, leaving me with n plus 1. Notice both binomials are the same. So I can GCF that out to the front, leaving us with 4n plus 5. We then set each factor equal to 0. And we solve each of those. And we think our answer is -1 and -5/4, but let's be careful. We have to account for the denominator. Can't be 0. Our denominator was n minus 5. So n can't be 5. That does not conflict with either solution, so these are our two solutions for this problem. Want to do another? Let's do it. Example 3. We have multiple denominators. No big deal. If I want to get rid of this x in the first term, I'm just going to multiply each term by x. That's going to get rid of that x. If I want to get rid of the x minus 3, I'm going to multiply each term by an x minus 3. You have to do it to every term. There are 3 terms. So this first term is just going to be an x minus 3 times 1, which is x minus 3. The next term, the x minus 3's cancel, so we just have a plus 1 times x, which is x. The next term, the x minus 3's cancel again, so we have an x times an x minus 2, which is x squared minus 2x. Let's get all the terms on the same side. The x, well, scratch that. If I combine like terms, the x and x is a 2x. Simplify each side before we get all the terms on the same side. If I subtract 2x and add 3 to both sides, I'm going to get x squared minus 4x plus 3. This is a trinomial. Lead coefficient is a 1, so I don't have to do anything fancy here. It just factors into two binomials. I need two numbers that multiply to get 3 and add to get negative 4. And those numbers are going to be a minus 3 and a minus 1. Negative 3 times negative 1 is positive 3. Negative 3 plus a negative 1 is a negative 4. Set each factor equal to 0. Solve those little fellas, and we think our answer is 3 and 1, but we got to be careful. Our denom cannot be equal to 0. Our denominator, one of them was an x, the other one was an x minus 3. So our answers are fine as long as they're not 0 or 3. One of the answers was supposed to be 3. So our answer for this is just 1, because once again, if this says it can't be 3 and this says it can be 3, can't wins every time. Number 4. I want to get rid of my fraction. I'm going to multiply every term by a 4n. If you want to multiply by more than 4n, you can, but you don't need to, because watch what happens. 4n divided by 4n cancels, so we got n minus 3. On the right, 4n divided by 4 is left with an n. 1 times n is n. Continuing on the right, 2n goes into 4n 2 times, so we have 2n plus 4. No more fraction. We also don't have any exponents other than 1, which we don't even write. So we can just solve this old school. If we subtract n from both sides, if we subtract 4 from both sides, we divide both sides by 2, we get n is negative 7/2, or so we think. We got to make sure our denominators can't be 0. So 4n can't be 0, 4 can't be 0, obviously, 2n can't be 0. Let me do better. I can do better. So we get n can't be 0, and n can't be 0. That does not conflict with our answer, so our answer is negative 7/2. Let's do another. Number 5, our denominator is quite the mess. I'm going to write this off to the side, and I'm going to factor it. It's a GCF of 3. This factors more. Notice that this denominator is the same as this one. So I'm going to rewrite this in the factored version. The reason I want to do that is so I can easily tell what I should be multiplying by. I don't want to multiply by anything more than I need to. You can, but it just makes it complicated. On the right side, the GCF is 3, so we end up with an x plus 2. Notice each denominator has a 3 and an x plus 2 in it. So if we multiply every term by a 3 times an x minus 3 times an x plus 2, that's going to fix us up here to get rid of our denominators. If your numerator has more than one term in it, you need to put it in parentheses. So on this first term, the entire thing cancels. We're left with a 1 minus. On the next one, 3 cancels, x minus 3 cancels, x plus 2 cancels, so we're left with an x plus 4. I intentionally left it in parentheses because of this minus sign. It's going to change some things. On the right, the x plus 2's cancel and the 3's cancel. Left with an x times x minus 3. I'm not sure what I just said. I think I said it wrong. We're left with a 1 times an x minus 3, which is x minus 3. If I distribute the negative, we're going to get 1 minus x minus 4 equals x minus 3. Uh-oh. No, maybe no uh-oh. If we combine some like terms, if we add 3 to both sides, we get negative x is x. If we add x to both sides, we get 0 equals 2x. If we divide by 2, we get x is 0. Or so we think our answer is 0. Let's take our original denominator, take every factor in it, and say it can't be 0. Let's see, my handwriting is so bad that I couldn't even read it there. This should be an x minus 3. My apologies. So we get x can't be 3 and x can't be negative 2. But we're cool with that because our answer wasn't that, it was 0. Number 6. If we were to multiply every term by the most complicated denominator of 6p squared, that's going to fix this up and not have any more denominator. 3 goes into 6p squared, 3p squared, 2p squared times. So we got 2p squared times 5, which is 10p squared. 2p goes into 6p squared 3p times. So we have 1 times 3p. And on the right, those cancel. Cancel means you're left with a 1. 1 times 1 is 1. Get all the terms on the same side. We're going to have to split the middle term and factor by grouping. This becomes a 5p plus a negative 2p minus 1. We got that because I needed to multiply negative 1 times negative 1 times 10p squared, so I need the product of negative 10p squared, and I need to be able to add to get 3p, and 5p and minus 2p do that. If I group the terms together, making sure there's a plus sign between the groups, and I GCF each group, I get the hotness that is here. Notice that the signs were different in the two different binomials. It's plus, plus, this is minus, minus. So I want to make sure I pull a negative out to the front of this so they have the same signs. Then, the binomials 2p plus 1 are the same. Pull that out to the front, left with the 5p minus 1. Set each factor equal to 0. I get 2p plus 1 is 0, 5p minus 1 is 0. I'm going to end up with negative 1/2 and 1/5. Or I think that's my answer. I have to make sure that my denominator can't be 0. So 3 can't be 0. No kidding. 2p can't be 0, so that means p can't be 0. Doesn't conflict with my answer. And I have a 6p squared can't be 0. So p can't be 0, which I've already established. Doesn't conflict with our answer, so our answer is negative 1/2 and 1/5. On the flip side, let's see. Let's do this one and be done with it. If time permits, if the bell rings, I'm going to have to cut out here. The first fraction factors into an m plus 6 and, no it doesn't, an m plus 2 and an m plus 3. So if I want to get rid of my denominators, I'm going to multiply every term by an m plus 2 and an m plus 3. There are 3 terms, so I'm going to multiply this 3 times. First fraction, I'm left with the 2. Second fraction, I got 5 times this product. Third fraction, the m plus 2's cancel. So I end up with 2m plus 6. If I distribute this 5 here, I'm going to get, I don't have time to finish this. The answer ends up being negative 13/5. So do the homework assignment. Hopefully that all made sense to you. Have a great day. Sorry I wasn't here today.